returns nothing. Print poly p. And simply int I think that's how we're going to do it. So how do we want to show this polynomial? Well, if p dot n is less than 1, this means the array is empty, right? So printf zero. Let's put a new line for now. This is the only polynomial which has no coefficients. It's 0. Okay, and return. Alright, so because we wrote it like that, after this point, we know p dot n is bigger than 0. We're going to assume that p dot coefs points to valid memory. Right? If you like, you can put a to-do there. Foolproof this, because what if somebody doesn't know that you assume that and he passes you a polynomial without actually putting anything in the memory? You should not crash the program. You should say what went wrong. But for now, it's all us, so let's defer that for now. Okay, so for I equals 0, I less than p dot n, I plus plus, actually the first case is probably okay, so we're going to print the polynomials backwards for now. If you want to modify it, that's fine, but for now we're going to print them backwards just because that's how we represent them in memory. And it's maybe less complicated, because we know the first one is at 0 and it's the constant. So okay, printf p.coefs 0, and then starting from 1, it's possible that this for loop is empty. What do? We print, so everything before that point printed, which means there's already everything. We need a space, we need a plus. Wait. If p.coefs smaller than 0, we printf directly I'll explain this stuff. If p.coefs is not equal to 0, could do all kinds of pretty things, like if the coefficient is equal to 0, you just skip, so you don't write the terms that are multiplied by 0. If it's equal to 1, you don't write the 1. If it's equal to -1, you just write minus. You could do all of these things, but they don't necessarily help you see what's going on inside the memory. So when we worked just to understand something, we'll leave that stuff out. line. Return. So let's have that gives us it's not it's not the prettiest thing in the world. Right? That's a little bit better, but still. I mean, it's not the prettiest print function in the world, but it does show you what I was trying to do. So that's the polynomial that we have, and that's how it's put in memory. All right. So what can we do with these polynomials? One thing we can do is we can take small polynomials and make bigger ones by combining them. For example, you can add two polynomials. So poly add poly P1 poly P2. How do you add two polynomials? Well, you gotta do two things. So first, int n1 int n if p1 dot n smaller than p2 dot n, n is equal to p2 dot n, else n is equal to p1 dot n. So it's going to be the max of n's. All right, if you add 1 plus x squared, it gives you x squared plus 1. So if you have a polynomial of length